All right, we're going to go over notes on lesson 3-7, slopes of parallel and perpendicular lines. So obviously we're going to have two lines. Either the lines are going to be parallel, they don't touch, or they do touch and they intersect at 90 degrees perpendicular. So here are 3 bullet points about parallel lines. If two non-vertical lines are parallel, then their slopes are equal. Now, of course, a line will have a slope number. Well, if those two numbers are the same, then the lines are parallel. Okay. This second bullet point is basically the first bullet point in reverse. If the slopes of two distinct non-vertical lines are equal, then the lines are parallel. And finally, two vertical lines, lines that are going just straight up, are parallel. So let's just see. Lines that are parallel will have equal slopes. So I've got a picture here, and basically these lines are parallel. They're never going to hit each other. And if I actually just count the slopes using this graph paper, this slope of A is 1, 2, 3 up, 1, 2 across, 3 over 2. So that means this slope should also be the same 3 over 2, thus making them parallel. So from this point to this point, it goes up 1, 2, 3 across 2, 3 up, 2 across. So those lines have the same slope number, so that's why they're parallel. Then they ask, this last bullet point says two vertical lines straight up and down are parallel. It's obvious that they're parallel. The reason why they're not comparing the slope numbers is because these slopes are undefined. They don't even have a number, so you can't just say this slope, which has no number, compare it to that slope, which has no number. But we do know that vertical lines are parallel. Okay, let's move on to perpendicular lines. Slopes of perpendicular lines. Of course, perpendicular means you cross at 90 degrees. The product of their slopes is -1. Product means multiply. If I take the slopes of the two lines and I multiply it, you should get -1. Or I like to use this one here. Perpendicular lines have opposite reciprocal slopes. So what does that mean? Well, opposite means one slope is positive, one slope is negative. Reciprocal means if one slope is 2 over 3, the other slope is 3 over 2. Again, opposite, one has to be positive going upwards, one has to be negative going downwards, and then the numbers have to be flip-flop reciprocal. And then you'll notice that's 90 degree intersection perpendicular. This guy here is the reverse. If the slopes of two lines have a product of -1, the lines are perpendicular. Let me also demonstrate on this previous example. If I take this slope 2, 3, and product means multiply it with this slope, -3 over 2, you get 2, 3, -6 on top, 3, 2, 6 on the bottom, 6 over 6 is -1. So whenever you get a multiplication of -1, whoops, I'm not on the screen, you will also have perpendicular lines. Okay, so you can either multiply them or just recognize, okay, one's positive, one's negative, one is 2, 3, the other is the flip of that, 3, 2. Perpendicular lines. Any horizontal line, this is the last bullet point, a horizontal line and a vertical line are perpendicular. All right, so let's just go to the graph paper and just see these scenarios. So I've got a perpendicular graph here. Right here, this is 90 degrees. If I figure out the slope of this first one, first of all, it's a positive slope. It goes up 1, 2 across 1, 2 over 1. So that's the slope of A. Slope of B is going downwards, so it's a negative slope. And I'm going to just take 2 points. I'll draw this point here and this point here. It goes up 1 across 2, rise over run. These are opposite reciprocals. One's positive, one's negative. One is 2 over 1, the other is 1 over 2. So these would be perpendicular. Or the other definition is if I take one slope and multiply it, the product, multiply it with the other slope, I should get a result of -1. 2 times 1 is -2, and that is 2, so that's -1. Okay. You can obviously see that they're perpendicular, but also using the slope numbers, you can tell that they're perpendicular. This last bullet point talks about a horizontal line and a vertical line are perpendicular. And the reason why they don't compare the slopes is because this vertical line is undefined. The horizontal line has a number, it's the number 0, but you can't really multiply 0 times undefined and expect to get an answer of -1. But we do know that these two are clearly perpendicular lines. So that's why we add this third bullet point. Okay, number 1A and 1B. Are the lines parallel? Well, all you got to do is compare the slope numbers, and if they are equal, then the lines are parallel. So for this first one, y is equal to 1/2 x plus 5, you should know that the number in front of x is the slope. So in this case, it's 1/2, negative 1/2. And this one is going to require a little bit of work because it's not in slope-intercept form. So let's move this x over, minus it over. 4y is equal to negative 2x plus 9. Divide by 4, divide by 4, divide by 4. Y by itself, because that's slope-intercept form. 2 divided by 4 is negative 1/2 x. 9 divided by 4 is 2.25. I'm not really concerned with that 2.25. I'm looking at the number that's multiplied with the x. I got negative 1/2, I got negative 1/2, so yes, these are parallel because negative 1/2 slope is equal to negative 1/2 slope. Or you could say no, they're not parallel because negative 1/2 is not the same as if this was 3/7, then you'd have two different slopes numbers. All right, let's move to number 1B. Again, here you got an equation, 1/2 x plus 5. So the slope number is pretty easy. It's negative 1/2. This one here, you're going to have to get y by itself. So I'm going to minus the 2x. Pretty much like I did the previous problem here, negative 2x plus 20, divide by 4, divide by 4, divide by 4. Y is equal to 2 divided by 4 is negative 1/2 x. 20 divided by 4 is 5. If you look at the slope numbers, negative 1/2, negative 1/2, you've got the same slope numbers, so you would think, yes, these lines are parallel, but in actuality, this is a trick question. No, these lines are not parallel because y is equal to negative 1/2 x plus 5, y is equal to negative 1/2 x plus 5. These are the same exact lines. And you can't be parallel when you're the same exact line. So this is just a trick question here. But realistically, had this been any number except the same number, this would have been parallel. Trick question. Okay, and finally, let's do this one here, number 2. Write an equation of a line that is parallel to this line and passes through this point. So you have a complete line here. I'll just say y is equal to negative x plus 4, but that's not the equation of the line that I want to figure out. I want to pass through this point, I don't know what it is, negative 2 comma 5. I want to figure out the equation of this red line here. What is this y is equal to mx plus b? Now since this red line is parallel to this black line, they must have the same slope. So the slope number here on the black line is negative 1. So that must be the same one here since the lines are parallel, negative 1 there. This is now going to be y is equal to negative 1x plus b in red. I don't know what that b is yet, but I do know this point passes through negative 2, which is an x, and comma 5, which is a y. So plug in the 5 here, plug in the negative 2 here. So I'm going to have 5, negative 1 times negative 2, and I'm going to solve for b. This is 2 negatives make a positive. Minus the 2, b is 3. So my equation for this red line is y is equal to the same slope, negative 1x. I don't even need to put the 1 there, but I can, plus 3. And that's the equation. Okay, of the line that's parallel. I actually drew this picture here. Parallel to y is equal to negative x plus 4 and passes through negative 2 comma 5. If I draw this correctly, what you'll see here is it has a y-intercept at 3. I didn't draw that very well. Okay. If they said the word perpendicular here, you would use this slope number and look for the opposite reciprocal of it. Okay. So whatever this black line slope is, do the opposite reciprocal. Since it was negative 1, which is negative 1 over 1, the opposite reciprocal would be positive 1 over 1. This had a slope of negative 1 over 1, so this red line would have been positive 1 over 1, and the procedure would have been the same if they used the word perpendicular.